In this video, we document and create our own cloud-based home lab using AWS services. Before we go into the steps, I want to first talk about why build a lab in the cloud and why not have it on-premises but on cloud. So there are a lot of benefits, but I want to talk about 4 specific ones. The first being cost efficiency. Building a lab in cloud reduces upfront capital expenses and offers pay-as-you-go pricing, optimizing costs for infrastructure and resources as you use them. For me, I found this one of the most important advantages or benefits, as you can call, for using cloud. The second being scalability. Cloud labs provide the ability to easily scale resources up or down on demand, accommodating fluctuations in workloads and ensuring optimal performance. The third being accessibility. Cloud-based labs can be accessed remotely from anywhere, and all you need is an internet connection, and that's all you need to basically be connected. And the fourth being high availability. Leading cloud providers such as AWS or Amazon Web Services offer robust infrastructure with redundancy and failover mechanism, which makes sure that normally you don't have next to no downtimes, and even if there's maintenance. Now as we move towards building our own AWS home lab, these are the 7 steps that we will go through in this whole video. So the first step that we go through is creating an AWS account. Then we go and secure this account using the MFA authentication. We will also talk about why it's important. We will configure the billing alarm, also talking about its importance, especially when you're using a free tier in AWS. Then we will go and create a non-root user. Then we will create a VPC and also talk about different steps that you can take while creating them. Then we will launch our EC2 instances, which will be both in Linux and in Windows. And finally, we will just terminate the EC2 that we actually create at the end. So the first step of doing this is that you actually create an AWS account. So for doing this, you first have to go, as I'm already logged in, I can show you this tab. Just go on Google and type free tier AWS. And when you go here, click on create a free account. Here you have to use the email address from which you want to sign in and the account name, and basically verify your email address. And after you do this, there will be a few questions, few details that you have to fill in. It's a normal form like you fill for any other signups. It's not difficult. Once you have signed in, once you have signed up to AWS and created your own account, after this point, the next step that we'll go through is secure the account using MFA authentication. So in this process, before we go and talk about as to what it is and how we do it, I want to just quickly talk about this multi-factor authentication and why it is important. So there are like 3 main benefits or main importance that I could find while I use multi-factor authentication for many things. So First is, you also know this as a security term, which is called best practice. So AWS considers the use of MFA a best practice for securing accounts. Following best practices for security reduces the likelihood of security breaches and demonstrates a commitment to protecting your AWS services. So basically adding additional level to your security and making it more robust. Then, as I already mentioned, yes, it also enhances the security. So MFA, or multi-factor authentication, adds an additional layer of security beyond just a password. To access the AWS account, users must provide a second authentication factor, which we will see how we do it. Typically something that they have. It can be a mobile device or a hardware token in addition to the password that you use. This significantly reduces the risk of unauthorized access, even if someone knows the password. So yeah, just as a very robust security level. And then the third is also, which is obviously related to security, is preventing unauthorized account access, where MFA helps prevent unauthorized individuals or malicious actors. This term malicious actors, if you have studied Security Plus or Network Plus, I think it's quite a common term that is used, from gaining access to your AWS resources, potentially causing data breaches, resource misuse, or financial loss. This is especially really important when you are an enterprise or a business. This data breach and financial loss can be a big factor. So before we go further, we just quickly check as to how can you do this. As I'm already logged into my account, the first thing that you do is go to security, go to IAM, it's the access management dashboard. Users, so here you will see your user already, which you have created. Then you click on it and go to security credentials. Here, if you do not have an MFA already, it will mention on top here that it's your whatever user that you're using, it's enabled without an MFA. You can just go and click here, assign MFA device. Then you have three options which you can choose. The most commonly used is the Authenticator app, which is quite handy. You can give a device name, anything that you wish to name. Select this option or any other option that you want. As I already had it, maybe I give a new name at this point. And then here you can get the QR code, and in the Authenticator app, the first two codes that you see, or the first two consecutive codes that you see, you have to fill it, and then you can add the MFA. That's how you add more security towards your account. The next step that we push to go through is configuring the billing alarm. Now, again, before going and doing it, I want to talk about why you should do this, or especially when you're using a free tier account in AWS, how big of an impact it makes. So it increases your cost visibility. So billing alarms provides increased visibility into your AWS spending. They allow you to track your expense in real time over specific periods, making it easier to monitor cost trends, identify cost spikes, and allocate resources efficiently. It also works as cost control. So AWS services are built based on actual usage. As you also know, it's one of the advantages of cloud. And cost can quickly accumulate because you often just work and you don't realize. Without a billing alarm, it's easy to overspend or exceed your limits, and potentially it can result in unexpected bills. So to have more control and make sure that you get an alert and make sure that you know what has to be done, how am I spending? Am I spending too much? Do I have to make sure that something has to change? This is where you can use the billing alarm. So now we can go and see as to how we can do it. So on your main dashboard, you can go on services. So here you can see that I have in your recently visited, but probably when you use it for the first time, you have to, your recently visited will be probably empty. So you go to management and governance, and here you can see there's CloudWatch. You go on CloudWatch. Afterwards, in the alarm section, there's a subsection called billing. You can go on billing and then just go and click on create alarm. So as I'm using this just for demonstration purpose, we will keep everything as default here, but this is basically the metric that you can design based on how you want it to be shown. Also, most of the things here, I will keep it just as default, and also further all the things that we do, most of the things which are not important for this demonstration, we won't go into details, we will just keep them as default. So here you can just type, let's say for 10 euros, we keep a threshold, and the moment we go over, so you can select whichever you want, but in this situation, if the expense goes over 10 euros, I will get an alarm. Just click next, and then you can create a new topic. We also here just keep it default, where you can also name, and here you mention which email address you want to get this response, you want to get this alert. So just for now, we keep it just the way is it, to just create a topic. Also and then it shows you that it's created, and you can click next. You can also name it, to give a tag, and here it says that sends us an alarm when threshold is reached. So here you can see that it's created. There will be a warning because the email address that I used is basically a dummy email. That's why it can't be confirmed, or it can't be, as you can see, it can't be confirmed. That's why it just says a warning. If you use your own proper email where you want it to get the alert, there won't be any warnings shown here. So moving on to the next part is creating a non-root user. Now, talking about creating a non-root user, there are also a lot of benefits for the same. And I will talk about 4 general benefits. Is that, again, it adds up the security. So the root account in AWS has full administrative privileges, as you probably have noticed when you created your account, meaning it can perform any action on any resource in your AWS account. Using a non-root user account limits the scope of potential damage in case the credentials are compromised. The next is using the least privilege principle, which is also a very important principle in security or cybersecurity, is following the principle of least privilege. Non-root user accounts should only be granted the permissions necessary to perform their specific tasks, which in general minimizes the risk of accidental or intentional misuse of the permissions. Then it also is used for MFA informant, which is it's easier to enforce multi-factor authentication for non-root user accounts. And as AWS recommends securing the root account with MFA, but enforcing MFA for non-root users is typically less challenging and it's more practical. And it also reduces risk of accidents, as non-root users' accounts have limited privileges by design. This reduces the risk of accidental or unintentional actions that could disrupt services, delete resources, or make unauthorized changes, as it does not have all the privileges to do it. So now to create a non-root user, you go to services, you go to security, identity and compliances, AM, and here on users, you go and click on create user. You can give it any other name which you wish. Then select provide user access, and here like that you want to create an IAM user. Now you can either have AWS create an auto-generated password, or you can click here and enter a password of your own. For this lab, we will just use the auto-generated password, and we will go and create next. Here you can add the user to a group. I've already created a group here, but just to demonstrate, I can show it again. You can name it any as you wish, and we give it the administrator access for this demonstration, but you can go and as per your usage, as per your demands, you can use whatever you want and click more policies. To creating this, you click which group you want it to be, click that, then you review and see whatever things that you have managed is correct or not, and then create user. Here you see the user instruction. You can download the CSV file, or you can email yourself the sign-in instructions. You can also click here to see the password. Let's go. And here now you can see that there's the new user which you have created, the non-root user, and in the root user group you can see that there's test group 1 and the username that you've created. Now moving on to our next step is creating a VCP. So VCP basically stands for Virtual Private Cloud, and it's a fundamental networking service provided by AWS. A VPC allows you to create and configure a logically isolated section of the AWS cloud where you can launch AWS resources like virtual machines. That is what we will see next step, EC2 instances. We can also use resources like database and networking components in a private controlled environment. So it's basically a network in the cloud, and it consists of 3 parts, which we'll focus in this demonstration, which is subnets. So first of all, talking about subnets, within a VPC you can create multiple subnets. Subnets are used to segment your network and allocate resources to a specific availability zones within an AWS region. Subnets can be public, it can be private, with or without internet access, depending on what you what you need. Normally, when we talk about internet gateways in AWS, an internet gateway is horizontally scalable. It's highly available and redundant component that enables communication between instances in your virtual private cloud, that is VPC, and the internet. It serves as a crucial component for connecting your VPC to the public internet and allowing traffic to flow in and out of your PC. And then when we talk about routing tables, in Amazon VPC, a routing table is a fundamental component that controls the routing of network traffic within the VPC. And we will see it how we can do this. A routing table consists a set of rules known as routes that specifically mentions how traffic should be directed between different subnets and destination within the VPC. So now we'll go and look at how we can do this. So now in this we go to networking and content and go on VPC. Here you initially can click on create VPC, which will give you a list, and this is basically a preview on how and what it looks like. It's a default setup. You can design on your own. We will change a few things. You can basically auto-generate the name, or you can also give it a custom name. We just let it auto-generate. This we keep as default, but according to what your requirement is, you can always change this as well. We will just keep as one availability zone. You can also customize your availability zone here, but we will just keep it default. As you can see, we just keep it default. And you just use one private and one public and no private at this moment. Keeping this none and keeping everything else the same. If you wish, you can select more public or more private subnets. You can also change the availability. You can change all the things here, but for demonstration purpose, we just keep it the way it is. It takes a bit of time, a few seconds to create, and then you will see that your VPC is finally created. Once you see this, you see all the details of this VPC. The next is you can go to your internet gateway here, and you will see the VPC here, which you created before. It's already attached. So here, when you click here, there's the option that if in case the internet gateway is not already formed, you can click here, create an internet gateway, and then select this internet gateway and then attach it to the VPC that you designed. Then we move towards the third part, which is the route tables. And here you see that there's two already created, and we'll go and create our own one more here. You can just name it or tag it with whichever name you want. You can select the VPC that you designed and then create a route table. So after creating the route, we want to edit this route, and then add a route which is 0.0.0.0/0, which is basically everything. It captures everything apart from this destination, and we want to send it to our internet gateway, which is here. That's what we created, and then save the changes. Then we want to go to subnet association and edit our subnet association, add this in, and then save the association. Next, what we'll do is creating security groups, which you can see also in the security section. And we want to create a security group. You can name it. This is just basically you defining it yourself, by adding the description for your benefit. In inbound rules, we add, basically you want all traffic coming in anywhere from IP6. So basically this, as it's just for the demonstration purpose, we use this things, but in general, when you are working or as an enterprise, you always want to use my IP, because where usually in an enterprise the IP is static, or when you're using this virtual machine where you personally will have different IP addresses, then you can select this as well. But this completely depends on what you want. We do the same here, is also adding the IP6 as well. After you're done this, you can click on create. After a few seconds, you see that your security group is created at this point. So now that we have created our security group, next we move on to our final two steps, which is launching the EC2 instance, which are, we will see here, is Windows and Linux, and then terminating the instances that we made. Now, what exactly is EC2? So Amazon Elastic Compute Cloud, Amazon EC2, is a core and fundamental service within AWS that provides scalable and resizable virtual computing resources in the cloud. So it's what you call virtual machine. EC2 allows users to launch and manage virtual servers known as instances to run application and workloads, and this contains a lot of different OS. We will see this when we go into this step, and the advantage that it launches quite quickly. So there are two ways in which you can launch your virtual machine. There's one which you can see directly on the console home. There's the option where you can choose to select this, or the second option is going to services, going to compute, and selecting the EC2. So this brings you to the EC2 dashboard. You can click on launch instance at this point, and then it gives you all the options that you can go through. So first we just name our web. You can name it as you wish. Now here you see the options of which OS that you can choose. There are many options. We first will do the Linux, and the second part we do the Windows. Make sure that you use the free tier eligible ones if you're using the free tier Amazon account, as we have selected the free ones. And also the instant type, it's the same, that you remember to choose the free tier one if you're using the free tier Amazon account for this. Now here, make sure to create a new key pair. We will talk about this more in detail in a couple of minutes why we do it. Here you have two options or two formats in which you can select. If you select the .ppk, it's more straightforward in coming steps when we launch our instance, but because it's a demonstration, we will select the .pem file format and then convert it into .ppk format. Name it and you can see that it's downloaded. In the network settings, you can either select your existing security group if you already have one, or you can create a security group here. For this demonstration, we select all the traffic, but when you create your own, make sure that you select it properly, and here either select custom or your own IP options. For the storage, it's the same, that we will keep everything default here at this moment, but this depends on what you wish to use, and you can configure based on that option. Now we go and click on launch instance. It takes up a few seconds to launch, and then you see that it's initiated. Now when you go, you click on your dashboard, you will see what you've created, and it takes a few seconds or sometimes a minute for the instance state to move from pending to running after it does all the security checks. Once it's completed, you can go and use the PuTTY configuration program and initially PuTTY key generator. If you did not choose the option of .ppk file format for your key, as we did not, we will use first the key generator, where we will import the key of .pem format and then save the private key in the form of .ppk. User A .ppk format. After saving, you can move to your PuTTY config, and in this instance we need the IP address. You can copy it here, and then at the host name you click paste. Then you can go to SSH. In auth, you go to credentials and browse the private key that you just converted and click on open. Here it will ask you for the username, and as you do not know the username, you can go first and click on connect, and here you see the username. Type it, and you see that you have successfully launched the Amazon Linux. Now, once you're done working in it, you can go and click on the instance state and click on terminate. You can choose to stop or reboot if you still will use this project, but as we have just created this for demonstration, we can click on terminate so that it does not use up all the resources. Here you will see that it's successfully terminated. Now we will launch the virtual machine in Windows OS. You basically go through a similar path. You can name anything that you wish. Make sure that you select Windows, and also make sure that you select all the free eligible ones. If you're using the free version of AWS, then you can go and create a new key pair. Once it's downloaded, you again create the security group, but make sure if you're using it for your own, again, that you do not select anywhere, but select either custom or my IP. And in this, we again just keep it as default and launch the instance. After a few seconds, the launching initiation is successful, and here you will see that it's pending, and in a few seconds or in a minute, it's up and running. So now, to launch Windows, you need the remote desktop connection, and for this you have two options. Either you can go and click run, and in run you can type mstsc, just like you see it here, and it launches the remote desktop connection, or you can directly search remote desktop connection. Now we'll click on options, and once it is running, click on the instance and go on connect. Once you go on connect, you click on RDP client. As for Windows, we connect through RDP, and then you download the remote desktop file. Once the download is complete, go back to the remote desktop and open the file. After opening, click on open and then click on connect. Say that you trust. Here it will ask you the password. Once you will see it here, that here you can see that you can click on get password. Click on this, upload the private key that you could see here. I will do it in a different place so that the key is safe. And then you decrypt, and after decryption you will see the password. You can copy this password and go on the remote desktop and paste the password. Click that you verify that it's your, and in a few seconds the virtual machine opens up, and here you can see that your Windows is now active and that you have successfully launched Windows. It takes a few seconds up to a minute to load completely Windows when you launch it for the first time. But also make sure that you see that this is the virtual machine and that's your actual computer that you're working on. And just as the same way that we used before, we can now click on terminate instance once you're done working on it. And after it's terminated, it does not take up any of your resources anymore. So this was about it, about how you can create and make your own host and create your own home lab in cloud, especially in AWS. And this ends the demonstration for this video.